Welcome to the Crazy Hat Chemist. Today we're doing the 14th video in a series of 23 on nuclear chemistry. So, let's get started. Bam! So, we're going to do half-life calculations. We're going to talk about a definition for half-life, and then I'm going to show you the math that's associated with it before we actually do any calculations. That will be in a future video. So, here we go. A definition of half-life. The half-life is the amount of time required for 1/2 of that radioactive material to disintegrate. So, I'm going to give my famous example. Unfortunately, it works out much better in my classroom because I have my lab bench. So I'm going to take this full sheet of paper. Do you see that? Full sheet of paper. Full sheet of paper. And in a half-life, which half-lives, by the way, can be fractions of a second to all the way up to billions of years. So, I'm going to take this full sheet of paper and I'm going to cut it in half. Bam! I'm going to cut it in half. Now, what do I have? 2 sheets that are half the size, each one of them from the original. So in a half-life, then I will have that remaining. Okay? Now, if I take another half-life, then I'm going to take this sheet of paper here, what remains, and cut that in half. So in a half-life, then this is going to be cut, and then bam, I'm going to get 2 of these right here. So what remains is that much. So this is 1/4, 1/4 of the original, what was remaining in the original sample. So I want you to keep that in mind. Okay, so let's discuss some of the math that's involved here. So this right here is called the half-life equation. So I'm going to delineate which each of these parts here is. This is the half-life. That's why it's T, that's for time, 1/2. So T of 1/2 is the half-life. Right here, this K is the rate constant. And then in the numerator is an ln2. That's the natural log of 2. So you're going to make sure that you find your calculator and find the natural log button. And then the natural log of 2 is a number, and that's 0.693. Okay, there are more numbers after that. Okay, this equation, this half-life equation, goes in conjunction with another equation. So they work in pairs. Okay, and this is the other equation here. This equation here is called the integrated first-order rate law, and you actually need calculus in order to do this equation. But you don't need calculus in order to do the math if you have the equation. So, depending on what your instructor or your teacher wants you to do, okay? So, parts of this are the following. This is the rate constant. See, the thing that's the same in both of these equations that holds them together is the rate constant. They both have the K, which is the rate constant. This T is time, and that time can be seconds, minutes, hours, days, years. It can be any unit of time, okay? And then this numerator, the X to the T part, X subscript T, is the amount of time, is the amount at time T. So how much you have at time T, how much remains at time T. And then this here, X sub 0, is going to be the amount at time 0, or the initial amount. Notice that there's a natural log there in front of it. Okay? And hopefully you know your rules for natural log, and that would be natural log of X sub T minus the natural log of X sub 0 is equal to negative KT. So I'm going to repeat that again. So it's natural log. When it's a division problem, it becomes a subtraction problem. So natural log of X sub T minus natural log of X sub 0 is equal to negative KT. Okay? I want you to keep that in mind as we do these. Memorize those 2 equations. Keep them into your heart. Notice that the K, the rate constant, is the thing that holds them together. I am the Crazy Hat Chemist, and I am wearing a flower hat today because, well, we're all flower children at one point or another. I hope you enjoyed that video. Give me a thumbs up if you like that video, and subscribe to my channel, and I will see you next time. See you later.